So in this section, we are going to do the fundamental theorem of algebra and then how to solve polynomial functions. For x, right, find zeros, right, where the degree is, especially when the degree is greater than 2. Now, so the idea is that, for example, if you have a quadratic equation like x squared plus 5x plus 6 equals 0, or a linear equation like 3x equals 9 or something, we know how to solve this using various methods, quadratic formula, factoring, and things like that. But if you get something like x cubed minus 5x squared plus 3x plus 2 or something equals 0, I mean, we don't know how to solve cubics or fourth degree. And there are advanced methods, but we will learn a method called the rational root theorem, which can help solve not all of them, but few of these cubic and quartic or fourth power of higher power equations, right? And we will be learning some methods to do that. But first of all, let's try to understand what the fundamental theorem of algebra is, which means that if you take a polynomial of degree n, degree is the highest power, then it has exactly n zeros. Polynomial function of degree n has exactly n zeros or n roots. So for example, if you have a quadratic, there are exactly two roots, but they can be complex or real. If it is degree 1, then we know that there is exactly one root. Degree 2, two roots. Degree 3 will have three roots, cubic polynomial. But the roots can be either complex or real. We don't know that. So let's do some exercises, right? So how many zeros does this function have? So don't be deceived by the x to the 1 here, because the high power, the degree is actually 4. The highest power is 4, so it will have 4 roots. Okay. But on the other hand, if you take something like this, right? Okay, if you expand this out, you'll get a quadratic x squared plus 6x plus 9, which means the degree is 2, so it will have two zeros. Okay. So then, so now let's go to the next result, which is the rational roots theorem. What we are trying to do is want to find the zeros of this polynomial. That means the roots as this equals 0. So rational root theorem is like, so this is a cubic, so we don't know a method as to how to solve this set, right? So we learn a method. Okay, so what we do is a rational number is a number which can be written as a fraction. So let's assume that our root is a rational root, so it can be written as a fraction. So we want to find out the possibilities for the top of the fraction, the bottom of the fraction, and then possibilities for the entire fraction, and then try out one by one. So the top of the fraction p, the theorem says that it has to divide the constant. It has to be a factor of the constant. So what are the factors of the constant 12? Okay, we know 1 is a factor of 12, 2 is a factor of 12, 3 is a factor of 12, and 4 is a factor of 12. Also, the plus or minus versions of those. So altogether, there are 2, 4, 8, and then of course there is plus or minus 6 and plus or minus 12. They are all factors of 12, which means actually the bottom p can take any one of those values, plus or minus 1, or plus or minus 2, or plus or minus 3, or plus or minus 4, plus or minus 6, or plus or minus 7. But can it take, for example, the value 5? No, because 5 is not one of the factors. So the top cannot be 5, or it cannot be 7, right? But it can be one of these, okay? Now the bottom, the possibilities for the bottom, it says is that bottom has to be a factor of the leading term. The leading term is the coefficient of the degree term. So the degree term here is 3. So the coefficient of that is 1. Okay, so the leading term has to be a factor of 1. So there are, now what are the factors of 1? The factors of 1 are very easy. They are plus or minus 1. So while the top can take these values, any one of those, the bottom can take plus or minus 1. So now we are going to do is match each one of these values and look at the possibilities. So when the top 1 matches with bottom 1, we get P over Q can get the value top 1, bottom 1, which is 1. Or you can match part top 2 and bottom 2, which is 2. Top 3 and bottom 1, again 3. Top 4 and bottom 1, which is 4. Top 6 and bottom 1, which is 6. Top 12 and bottom 1. So what you're going to do is any one of these matches with any other things on top, with anything in bottom can be a match. So how many possibilities will you get? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So 1, 2, 3, 4, 5, 6. Altogether 12 possibilities. Now, these are only the possibilities, right? This doesn't mean that this has to be the roots or the zeros. So we need to try them out. So the best way to try them out is that we know that if, say, for example, if 1 is a 0, we don't know, is a, or a root or a 0, then x minus 1 would be a factor. So we can do synthetic with x minus 1 and see whether the remainder is 0. If the remainder is 0, then we know that it's a 0. So we had to try each of them, but luckily, in these problems, when you go to it for an exam, usually we will get a 0 within the first 4 tries or whatever, okay? But you have to do the tries carefully. So let's try, for example, here to see whether negative 1 is a root, okay? So our question is whether negative 1 is a root, okay? Okay, and then what happens is if you want to take negative 1 and see, we are going to do a synthetic with x plus 1. And then how do you do synthetic with x plus 1? We put the negative 1 there and we take our original polynomial. So and look at the coefficients. So you get 1 x cubed. There is no x squared. So 1, 0, negative 13 and 12. So 1, 0, negative 13 and 12. And then we do synthetic. 1 goes down. 1 times negative 1 is negative 1. Negative 1 goes plus negative 1 plus 0 is negative 1. Negative 1 times negative 1 is 1, goes up here. 1 and negative 13 is negative 12. Negative 12 and 1 is positive 12. Positive 12 and positive 12 is 24. The remainder is not 0. So this is not a 0. Okay. But if you take another possibility, now we took care of one. Negative 1 is not true. Let's take positive 1. So we take positive 1. Again, the first row is the same. 1, 0, negative 3, 12. We are just trying to see whether it's a root. That means we are trying to see when you divide by x minus 1, whether the remainder is 0. If it is 0, then it's a root. Okay. So we take 1. So 1 goes down, 1 goes up, and then 1 times 1 is 1. 1 times 1 is 1. Negative 13 plus 1 is negative 12. Now into negative 12 plus times 1 is negative 12. And when you add the 2, you get 0. So we do get a 0 remainder. The fact that we get a 0 remainder means that x minus 1 is a factor. So that means this is a root. So we have a root now. 1 is a 0. All right. So now we know that this is power 3. So actually we need to get 2 more roots, right? Because we got one of them now. We need 2 more. Okay. 2 more zeros. Okay. So now how do you find that out? What to do is we go to the we look at the one that we got where we got the root. This is the synthetic for that. So we look at the quotient here. When you look at the quotient of this synthetic, we know that the quotient has to be what? X squared plus x minus 12. So x squared plus x minus 12. We said that equal to 0. The point is this. So if x minus 1 is one of the factors, right, the other factors must be here in the quotient. So that's why we take the quotient and set it equal to 0. And then we do that, we get x plus 4 and x minus 3 equals 0. We get x minus 4 and x equals 3. So really we get all 3 zeros now. One is negative 4, other one is 3, and the other one is 1. We got 3 zeros, so we were able to solve our first cubic equation. Okay, so now let's do another problem. So in this problem we wanted to solve x cubed minus x squared plus 2, right, and find out its zeros, right? Okay. So then if you look at P over Q, the P has to be a factor of 2. So the possibilities are plus or minus 1, plus or minus 2. Q, the bottom has to be a factor of the leading term, which is 1, plus or minus 1. So if you match each of these, you get what? The possibilities are plus or minus 1, 1 with 1, plus or minus 2 will be 2 with 1. Okay. So how many are there? 1, 2, 3, 4. 4 possibilities. So let's try the easiest one first. We'll start with 1 or negative 1. And then you will show that when we start with negative 1, you can start with 1. We actually can show that when we do negative 1, we get 0. Synthetic, I'll leave it to you. So which means negative 1 is a 0. So now we want to get the other 2. So what you do, we go to the quotient and set it equal to 0. So the quotient will be x squared minus 2x plus 2 equals 0. Now this cannot be factored, so we have to use the quadratic formula for that. So when we use the quadratic formula, we get this, and b squared would be negative b would be 2, b squared will be negative 2 squared, which is 4 minus 4 times a, which is 1, times 2, which is 8. So 4 minus 8, we get 2i. And then, so that's a negative, so because that is negative square root of negative 4 here, which is 2 times square root of negative 1, which is I. So 2i, and then the 2 cancels off, and we get 1 plus or minus I. So we get the other two zeros are 1 plus I and 1 minus I. And then, so we have all three. What are the three? We have negative 1 from here, and then we have 1 plus I, and then we have 1 minus I. So these are the three zeros. It has to have three zeros because it is a cubic. So finally, we'll do a problem that again, how to factor. So we will actually now do a problem. So where if you are given some of the roots, how do you get the polynomial? So the question we have is find a polynomial with zeros 2 and 1 plus I. So the trick is, if 1 plus I is a root, then there is a theorem which says that 1 minus I is also a root. Okay, so if the conjugate, so 1 plus I is conjugate, 1 minus I is also root. So when they tell you that 2 and 1 plus I are roots, we automatically know that 2, 1 plus I and also 1 minus I are roots. So we have three roots. So to create the polynomial, it's very easy. If 2 is a root, then x minus 2 is a factor. If this is a root, then x minus that is a factor. If this is a root, then x minus that is a factor. Then what we do is we multiply these two factors. So the first factor is this factor, second factor is this, and third factor is this. And when we multiply this x minus 2 and then we distribute this, we get this, and which simplifies to this. I will leave it to you. And then we distribute x minus 2, we FOIL it, and finally we get this, which turns out to be this. So that's the polynomial whose roots are 2, 1 plus I, and been automatically 1 minus I is also a root. Okay. One last topic, and that is how to factor higher degree polynomials, right? And so here, there are two ways of doing this. One way is to use the rational root theorem and find the zeros, right? And then kind of factor this, right? Okay. And once you know the zeros, you can create the factors. But this one is easier. Now you can use grouping because negative 27 does have factors which add up to 6, right? What are those factors? 9 and negative 3. So we have done this many times before. What we do is we split the middle term 6 as 9x squared and negative 3x squared. And then what we do is we take 2 by 2 and take the common factors. And then we get this. But final step, we need to factor this one. So x squared minus 3 can be factored as x plus 3, square root 3x minus square root 3 using difference of squares. This x squared plus 9 can be done the same, but you need to put an I because it's plus 9 and square root of negative 9 is square root 3i plus or minus. Okay, and that's it for this video.